Hello students, and welcome back to another algebra video. You know what to do. Pause the video, answer these questions in your notes, and then unpause the video, and let's talk about them. So the first question is, what is a linear equation? Now, Chapter 3 and Chapter 4 were all about linear equations, so hopefully you wrote something in the form y equals mx plus b, slope-intercept form, or you could have used point-slope form and written something in that form, or we also have standard form of a linear equation. So any one of these things you could have written down, of course with numbers in exchange for certain variables, but any one of these forms would have worked to create an example of a linear equation. Now, so that's review. Hopefully you remember that. But now, what is a system of linear equations? Equations plural. What is a system of linear equations? Well, maybe you could have guessed something like, well, linear equations plural, so maybe I should have, 3 or, multiple 2, 3 equations together, and that makes a system? Or maybe you were just completely confused and you were like, I have no idea. Either way, this is what Chapter 5 is all about. It's about systems of linear equations. So, if you weren't able to write an example, that's okay, but at least you got yourself thinking about what is a system of linear equations. So, that is what we are going to be talking about in Chapter 5. Let's get started with what we have for today. Today we are starting Chapter 5. We are starting Section 5.1. So we are going to be solving systems of linear equations by graphing. So the question that we want to know the answer to is, how can you solve a system of linear equations? What does it mean to solve a system of linear equations? So our learning target is that you know what a system of linear equations is, and our success criteria is that you can find solutions of systems of linear equations and check solutions of systems of linear equations from a graph. So you can find and check solutions of systems of linear equations using a graph. So, first, we need to know what is a system of linear equations. So, this is very similar to what we talked about in the entry task. A system of linear equations is a set of 2 or more linear equations in the same variables. Now, I know you might be thinking, Mrs. Dodge, I have no idea what that means, but in the same variables means we have y and x in equation 1, and in equation 2, we're also using y and x. So we're using the same variables in both of our equations. If I switched from y and x to like z and x, well now wait a minute. These are not in the same variables. So the equations that we care about, the systems of equations that we care about, are in the same variables. So you can have 2 equations, or you can have more. We could have 3, we could have 5, in fact, you can have 27. And that actually gets into, there's a field of mathematics called linear algebra, which is all about writing systems of linear equations as matrices. And that way you can deal with a system of 27 linear equations, and you can work with them much more easily. So if you enjoy Chapter 5, you might enjoy linear algebra. Who knows? Okay, but, so we can have 2 or more of these equations. They need to be linear. For our purposes, they need to be linear. And remember, linear means that there's no exponents, there's no variables in the denominator, There's no variables in the exponent, none of that. None of that, just normal x, normal y. Okay, all right, so that's what a system of linear equations is. Now, what is a solution of a system of linear equations? Because remember, our success criteria was that we can find and check solutions of systems of linear equations. So, a solution of a system of linear equations is an ordered pair. So stop and think, what is an ordered pair? An ordered pair is a set of coordinates, right? A point where I have an x coordinate and a y coordinate. So the solution is going to look something like a point, an ordered pair. And an ordered pair, that is a solution of each equation in the system. So in the end, we're going to get an x and a y, and that x and y needs to work in both of these equations. It needs to work in both of these. So I need to get something that is true for equation 1 and something that is true for equation 2 when I plug x and y into them. Okay. And if you're confused and you're like, Mrs. Dodge, I'm not 100% following what you're saying, that's okay, because we're going to see some examples in just a second. So let's recap everything that we've talked about, make sure we're on the same page. A system of linear equations is a set of two or more linear equations in the same variables. So an example is shown below. This is a system of linear equations. Okay, and a solution of a system of linear equations in two variables, so this is if we're talking about two variables, is an ordered pair, x, y, that is a solution of each equation in the system. Now, if you have more than two variables, if we have like, we have x plus y plus z equals 7, and 2x minus 3y minus 4z equals negative 11, well then we would need another point in this ordered pair. We would need x, y, and z in our point, in our solution. So for our purposes, we are just going to be talking about two variables. 3 variables, you'll get into that in multivariable calculus. But for now, we're in algebra. So we're going to be working with just 2 variables. Just x, just y. Keeping things simple. Okay, so let's go ahead and see our first example of chapter 5. Checking solutions. So this was part of our success criteria. We want to check the solutions for a system of linear equations. So what we're going to do is we're going to take our point, the point that they give us, and we want to know, is this ordered pair, is it a solution? Is this point a solution to this system of equations? So I know that in ordered pairs, x comes first and y comes second. So I have x and y. X is 2, y is 5. And what I'm going to do is I'm going to plug in 2 for x. And I'm going to plug in 5 for y. And we want to see, do we get an equation that is true? So let me show you what I mean by that. We're going to take the first equation, equation 1, x plus y equals 7. And I'm going to change x. Instead of writing x, I'm going to write 2. Because x is 2. And this is equation 1 that we're working with. So I'll put a 1 next to it like that to say that this is equation 1. All right. And instead of writing y, I'm going to write 5. Because y is 5. 2 plus 5 equals 7. Is that true? Well, 2 plus 5 is 7, and yeah, 7 equals 7. So equation 1 is true. This point, 2, 5, works for equation 1. It is a solution of equation number 1. But it's not enough for it to just be a solution of equation number 1. I need it to be a solution of both equations. So now I'm going to look at equation number 2. 2x minus 3y equals negative 11. And I'm going to change the x to 2. So 2 times 2 minus 3 times y is 5. Is that equal to negative 11? Yes or no? Well, let's see. 2 times 2 is 4. Remember, I do my PEMDAS, so I'm going to multiply before I subtract. 2 times 2 is 4. Minus 3 times 5 is 15. Is 4 minus 15 equal to negative 11? Let's see. Yes, I believe so. We can always check with our calculator. Yes, perfect. This is true. So, because this point works for both of the equations, yes. We say, yes, this point, 2, 5, is a solution to this system of equations. So, yes. Now, what I'd like you to do now is pause the video and try part B on your own. See if you're comfortable enough to try part B on your own. If you're not, if you're like, wait a minute, I still am not totally sure what's happening, that's okay. We can do it together. But I'd like you to try to do it on your own. That way you can think, what questions do I have about this? So that you know what to pay attention to when I'm doing it. So try it on your own, unpause it, do it with me. All right, we have that x is equal to negative 2 and y is equal to 0. So we're going to take equation number 1, y equals negative 2x minus 4. And we're going to plug in, instead of writing y, we're going to write 0. And instead of writing x, we're going to write negative 2. Whoops, negative, negative 2 minus 4. Okay, so, and in fact, we could use parentheses here instead of the dot, because that makes it easier to see. Negative 2 times negative 2. All right, and negative 2 times negative 2 is positive 4. Positive 4 minus 4, hey, that's 0. We get 0 equals 0, and that's good. So yes, equation number 1 works. What about equation number 2? Equation number 2, y equals x plus 4. So remember, I'm going to replace y with 0, and I'm going to replace x with negative 2. So 0 equals negative 2 plus 4 is 2. Oh no! Is 0 equal to 2? No, this is not right. This is wrong. So, no. The point negative 2, 0 is not a solution to this system of equations. Because, it worked for equation number 1. It was fine for equation number 1. But for equation number 2, it was not okay. And remember, in order for a solution to be a solution, or excuse me, in order for a point to be a solution, it needs to work for both equations in the system. So, the answer to part A was yes, because both of them were good. The answer to part B was no, because one of them was not okay. Okay, all right, we can check and make sure that we were correct. Oh, whoops, haha, I left myself more space for part B, but I didn't need to. Oops. Okay, we can check and make sure that we were correct. Let's see. Because the ordered pair 2, 5 is a solution, yes, they said yes. And aha, look at that. They said no for part B. So yay, we were correct. And now we move on to the next part of our success criteria, which was finding solutions with a graph. Finding and checking solutions with a graph. So now we're getting into how to solve a system of equations by graphing. So here's where our graphs come into play. So, how do you solve a system of equations by graphing? We know what a solution looks like. A solution looks like x, y. And so far, all we've done is check these points. But how can I find this point? If you tell me this is what the system is and you don't tell me the point, how can I find the point just by being given the system of equations? Well, one way to do that, and we're going to learn 3 ways to do it, one way to do it is by graphing. So, in order to do this by graphing, there are 3 steps. Step 1, graph each equation in the same coordinate plane. So the same coordinate plane just means on the same graph. Excuse me. So draw each line, draw the equation of each line on the same coordinate plane. Step 2, estimate the point of intersection. And we're going to rewrite that in easier words. Where do the lines cross? You want to find the point where the lines cross. That's what step 2 is. All right. And step 3, check the point from step 2 by substituting for x and y in each equation. So what that means is do example 1. What we just did in example 1, we checked, was this a solution or not? We want to do that as our step 3. We want to make sure that we found the right point where the lines crossed. So those are your 3 steps. 1, graph the lines. 2, where do the lines cross? 3, make sure that you are right. Alrighty. So, let's go ahead and do an example of this. So, use the graph to solve the system of linear equations and check your solution. So, notice that they already did step 1 for us, and this is why it's example 1.5. It's not example 2 yet, it's example 1.5. Because they already graphed for us. They did step 1. Graph each equation on the same coordinate plane. They did that. So now what we want to do is we want to do step number 2. Estimate the point of intersection. Where does it look like these lines cross? Well, it looks like they cross right here. It looks like they cross at this point. At 1, 2, 3, -1. Oops. 3, comma, -1. It looks like they cross at 3, -1. So that's step number 2. We estimated where the lines crossed. We think it looks like the lines cross at 3, -1. So now we need to check our solution. So we're going to plug in 3 for x and -1 for y into both of our equations. So first, equation number 1, we have -1 equals 1/3 times x minus 2. So this is equation number 1. I just replaced x and y with 3 and -1. Okay. So we have -1 equals, let's see, 1/3 times 3. Remember, I can put a 1 under the 3 and multiply across, so I get 3 over 3. Oh, that's just 1. That's just 1. So we get 1 minus 2. And if you don't remember how to multiply your fractions, that's okay, but be sure to ask your teacher about it so that they can help you with it. Okay, so is -1 equal to 1 minus 2? Yes. Yes, it is. Aha. Okay, good. This is a good sign because it means that our point was correct for equation number 1. Now, we just need to check and make sure that it's okay for equation number 2. So equation number 2, we have y equals 2/3 x minus 3. And remember, I'm going to replace y with -1, and I'm going to replace x with 3. It's a big 3. I guess it doesn't matter. Now I have -1 equals, another way of thinking about multiplying these fractions is there's a 3 in the bottom and a 3 on the top. So these just cancel out, and I have 2. 2 minus 3. That's another way to think about it. Okay, is -1 equal to 2 minus 3? Yes. Yes, 2 minus 3 is -1. And hey, it works. Our point, 3, -1, works for both equations. So, our solution is 3, -1. And that's our answer, our final answer. Awesome. Okay, so now let's check our answer. Example 1.5, solution. The solution is wherever the lines cross. So for this example, the solution was 3, -1, because it is the point where the two lines cross. So remember that each equation in your system is represented by a line on the graph. All right, let's go ahead and move on to assessing our understanding. So, now is a good time to pause the video and think about our learning target and our success criteria. How do you feel about our learning target and success criteria? Do you know what a system of linear equations is? And do you know how to find and check solutions of systems of linear equations? Remember, oh, that's my cat's jingly bell. Remember, rate yourself on a scale of 1 to 3, where 1 is sad, or what? 1 is sad because I have no idea what's going on. 2 is, I think, maybe, I'm not sure. And 3 is, oh yeah, I could help a friend with this, I could teach a friend how to do this, I feel so confident. So if you're a 1, definitely reach out to your teacher, ask some questions, call a friend, see if you can get help, watch another YouTube video, a Khan Academy video, something like that. If you're a 2, trying the homework is your next step. You're probably ready to try the homework, and as you work on the homework and struggle through it and find success there, it will solidify your learning. And if you're a 3, reach out to a friend. Call a friend, see if they need help. Teach your parents about what you've learned. And yeah, help other people. Okay, all right, here are some practice problems that you can do to practice the skills that you have learned in this video. These problems are like example 1, and the second set of problems are like example 1.5 that we did. We're going to talk about example 2 in the next video. Alrighty, and as always, let's end our video with a launch, shall we? So, today's launch comes from an unknown person, but it is wonderful nonetheless. It says, be so busy loving your life that you have no time. You have no time for hate, regret, or fear. And I love this quote. Be so busy loving your life that you just don't have time for hate, regret, or fear. Hate, regret, and fear are really easy. And in fact, I find myself in regret and fear more often than I'd like to be. And I have to stop and go, wait a minute, that's a regret. We don't need regret. Wait a minute, that's fear. We don't need fear. So if you can focus on, when it says be so busy, if you can focus on loving your life, loving the people that are in your life, loving the situations that you create for yourself, loving the opportunities that you create for yourself, loving other people. If you are so busy focusing on love and creating love for yourself and those around you, you think about hate, regret, and fear less. They don't really come to mind as much because love is so powerful. And I know that sounds cliche and lame, but it's true. Love is so powerful that it can defuse hate, regret, and fear. So when Mr. Dodge and I get into an argument, I could hate him and lash out, or I could overwhelm him with love, and we can come together about the situation and be better for it, instead of, end up hating each other and regretting that we got married. We can come together and we can be so busy loving each other that we don't have time. We don't have time to fight or argue or hate each other or anything like that. And of course, this extends past marriage. This is all around in your life. You can hate bullies or you can love them. You can hate teachers or you can love them. This goes with anything. So be so busy loving your life that you don't have time. You just don't have time for all these negative emotions because you're so busy loving your life and the people in your life and yourself. Love yourself. That's important too. So be busy with love. That is my launch for you today. Take it with you as you go throughout your day. Have a wonderful rest of your day. And thanks for being here. Thanks for watching. Bye.